Okay, so what we're going to do is we're going to introduce similar figures. And similar figures have certain characteristics that make them similar. So the first characteristic is you have to have the same shape. So generally what they mean by that is you can't compare a triangle to a rectangle. So a triangle and a rectangle can't be similar. They have to be the same shape, but they technically really don't have to be the same size. So number two, the corresponding angles have equal measure. Means that their corresponding angles are congruent or equal. Like, so if this angle A is 90 degrees, the corresponding angle D has to be 90 degrees as well. And the last one is corresponding sides are proportional. So the sides don't have to be equal per se, but they have to be proportional. It means that they are going up at a proportional rate. So that means we're going to be using proportions to see if they're similar and also to find missing sides. Before we do that, you'll see the symbol on the star, and this means that it is similar to. So it would be like A, B, C is similar to D, E, F. Okay, so I call this squiggly line. That's not the proper name. The proper name is called a tilde. I just call it squiggly. And again, you don't need to know the name, you just need to understand what it means. Hey, first example. So it says write a proportion. Well, since I'm not missing any sides, what I'm going to do is I'm going to determine if the triangles are proportional, or similar, excuse me. And they actually are. And the reason why I tell you this is because I want to show you something we can do with this. So we have triangle ABC is similar to triangle DEF. Now, we're not going to use this a lot on this lesson today, but what we're going to use this tomorrow, but it comes in handy, and I'll show you why. So you take ABC over DEF. Okay, so ABC or DEF helps you determine which letter goes to which. So A corresponds to D, B corresponds with E, and C corresponds with F. So if you take the length AB, that goes with DE. If you take the length BC, that goes with EF. And then AC goes with DF. This helps you figure out what goes with what, because sometimes your shapes will not be the correct, they will be rotated, so it'll be harder to see which side it goes with what side. All right, with that said, let's prove that these are similar. So I'm going to take length AB, which is 6. Well, AB goes with DE, so it goes with 3. So it'll be 6 over 3. And since I started at the left triangle, I'm going to go back to the left, go to 10, and then we know 10 goes to 5. And so that's our proportion. Some of you might already see that 6 divided by 3 and 10 divided by 5 is both 2. So they're already equal. If you don't see that, it's perfectly fine. What we're going to do is we're going to cross multiply. So you're going to do 10 times 3, which is 30. And then 6 times 5, which is 30 as well. And then 30 and 30 are both equal, meaning that these triangles are proportional with each other. They're similar. All right, now let's do one with a missing side. We don't have this missing, we don't have this side, so it's missing. So we're going to label this X. When I have a missing side like that, I always like to start with the variable, so X. And so that'd be X over this other side will be 3. That means I got to go back to this rectangle or parallelogram and go to this one, which would be 16 over 8. So now we cross multiply. Well, 16 times 3 is 48. 8 times x is just 8x. Divide by 8 is 6. So our missing side is 6. All right, next example. Well, this one has 2 missing variables. All right, so again, I'm going to start off with my x. So the x over the corresponding side of 4. And then I have 2 numbers on this triangle that I haven't used yet, and that's perfectly okay. But this 3 corresponds to a y. So I don't know what the length that they correspond to, so I can't use it because I can't have two variables in a proportion. So what I'm going to use is I'm going to use this 4 to this 8. So it'd be 4 over 8. So 4 times 4 is 16. X times 8 is 8x. So you divide by 8 to both sides. You get 2 equals x. And that's your answer for x. And we're not done with this problem yet because we have 2 missing variables. What I am going to do is make this x equal 2. Now I want to solve for the y, like we've just been doing. So be y over what it corresponds with is 3. And now this triangle still has two sides, but I can use either one because 4 goes to the 2 and 8 goes with the 4. So I don't care which one I use. I'm just going to use the 4. So it'll be 4 over 2. 4 times 3 is 12. Y times 2 is 2y. Divide by 2 is 6. So y equals 6. And that's how you find missing sides. All right, last one would be a relatively close star question. So it says the sail shown below have a horizontal stripe parallel to the base of the sail. What's the distance x from the bottom of the sail to the stripe? So I'm trying to find this length from E to C. Okay? All the other problems we looked at had two shapes being compared to each other. Well, this is one shape, but it actually has a shape within it. And those are harder for me to read. So what I'd like to do on these problems is to break it up. So I'm going to redraw my shapes. So the length of AC is 12. And then I don't know the length of BC. BC has 10 and an X in it. So I don't know the full length. So what I'm going to do is I'm going to label this Y. Then I'm going to draw the little baby one. Okay, so length of DE is 4.8, and the length of BE is 10. Well, I'm going to ignore this one over here. Instead, I'm going to go use these two triangles I just created to figure out what Y is. So Y, we're just going to set up a proportion, be Y over 10 is equal to 12 over 4.8. So I do 12 times 10, which is 120, and 4.8y. So I divide 4.8 into 120. You can't have a decimal, so you move it. 48 goes into 1,280 25 times. So y equals 25. Now, that's not our answer because what we just figured out was his entire length BC. That entire length BC equals 25. Part of it is 10, while the other part we don't know. So what can I add to 10 to get to 25? Be 15. So x would equal 15. All right. Thank you, guys.